All right. So, hello and welcome everyone. We are live again, right? So, welcome all of you to this particular channel, Pradhan Academy. And today we're also going to discuss the upcoming topics of algebra for JEE Advanced Maths, right? So, today I have taken up the topic of binomial theorem, right? One of the very interesting and easy chapter. And because you need to have a good base in binomial theorem in order to solve questions of sequence and series. And even in questions of complex numbers also, sometimes these ideas of binomial theorem is very crucial and important to understand. That's why I have taken up the binomial theorem as a continuation of the algebra portion for JEE Advanced Maths, right? So if you're new to this particular channel, I would consider saying that please consider subscribing and please don't forget to hit the bell icon so that you don't miss out any upcoming notification, right? We are coming live every day and in order to help you out with your upcoming exam preparation. Not only JEE Mains Advanced as well as it's also for NEET and the upcoming examination like BITSAT, right? So all things will be taken care of once you start watching the session. Okay. So let's get started for this particular session today. Today we are going to discuss the binomial theorem, right? Now I understand that you have already cleared your JEE Mains, so you must have done quite a bit of good revision for binomial theorem, right? So, but again, note of word, before you start, do have a revision on NCRT and also prepare the NCRT exemplar questions, okay? Before you start up or head up to get to the start of this binomial theorem, right? Because it's very important to have a quick understanding about the basics part before you start to solve actual questions. Alright, so with that particular note, keeping in mind, let's get started. And along with that, I would request all of you to please make sure short notes, okay? Because short notes is very important, especially for quick revision before exam, okay? So keeping all those things in mind, let's get started. So, and there is a very good news for all of you that we are going to start up live classes, live online batches for 2026 and 27 year JEE Mains and JEE Advanced students, okay? To get more information about these particular sessions or classes, please contact this number given over here, right? Please contact this particular number given over here. The price is starting just as rupees 999. The price is starting just as rupees 999, right? So please make sure that you enroll for these batches on time. So because we are going to start this live classes very soon. Okay. If you want to get more information about this batch or how this batch is going to take about or go on and what is the schedule of the batches, you can always contact and get information about that particular thing from the number given over here. So don't forget to contact the number over here and make sure that you enroll for the upcoming classes over here. Right. So with this, let's get started. Right. So today our goal is to discuss the JEE Advanced previous year questions of binomial theorem. Along with that, we are going to practice both MCQ and numerical type questions and all integer type question as well. Okay. Now, especially I will take in mind taking thing that you have to prepare for the upcoming JEE Advanced exam. So I am taking up the question accordingly, right? So if you feel that there is a difficult problem anywhere, or if you feel the questions is not able to understand, or you are not able to understand any of the part of the question, please don't feel left out. Okay, don't hesitate to ask a doubt in the live chat. Okay, I'm watching the live chat. Please put in a question if you have any question. Okay, and if you're watching the session after the live class is over, you can always put your question in the comment section. I will try to help you answer your doubts as soon as possible. And if you want to get access to this particular lectures, notes and material and mock test for your upcoming JEE Mains and advanced examination, you can always join our Telegram channel. The link is in the description. Okay, so please join the Telegram channel. The link is in the description. Okay, you will find the link in the description. So with this, let's get started. Class 11, hello. Alright, so let's get started with the very first question is on your screen. Please try to solve this question. Now before I start, I would like to tell you that if you look at the chapter of binomial theorem, the different types of questions that you are going to encounter are most probably will be the questions where you have to basically be finding out the general term. From the general term understanding, you have to find out either the middle term or the greatest coefficient or the coefficient, right? So in order to solve those kinds of questions, it is very important to have a good understanding on the concepts of the general term for binomial expansion. Okay, so if you look over here, So if you look over the expansion over here, right, the expansion is mentioned as ax square plus 70 upon 27 bx, 70 upon 27 bx whole to the power 4. That is the given binomial expansion, right? Now it is said that the coefficient of x to the power 5, coefficient of x to the power 5 in this expansion, is equals to the coefficient of x to the power minus 5, right? Now before we start to discuss about the questions on the binomial coefficient, let's try to understand coefficient of x to the power minus 5 in the expansion of ax minus 1 upon bx square whole to the power 7, right? So before we start to discuss about it, let us have a quick recap on what is a general term. So let's say if we have a binomial expansion which is of the form x plus y to the power n, in this case I can write this particular summation as equals to r going from 0 to n. The general term can be given as NCR x to the power n minus r and y to the power r, x to the power n minus r and y to the power r. So therefore this particular term that you can see over here is generally called as a general term. So it is called the general term r plus 1, right? So it is general term r plus 1. I hope this part is clear, right? Now let's try to find out what is the general term of this particular expression, right? So if you look at from this particular part, if you look at the general term from here, then the general term can be given as 4cr ax square whole to the power 4 minus r into 70 by 27 bx whole to the power r, right? Similarly, if I look at the general term of this particular expansion, then the general term of this particular expansion can be given as 7cr ax whole to the power 7 minus r and then multiplied with minus of 1 upon bx whole to 1 upon bx square whole to the power r, right? So if I try to understand, first of all, if I try to understand what is the coefficient of x to the power 5 from this particular expansion, so what I will get is there from the first expansion, if I look over there, then it is basically 4cr and we have ax square whole to the power 4 minus r and then we have 70 upon 27 bx whole to the power r, right? So if I try to find out the power of the x, I will get x to the power 8 minus 2r minus r, right? So that is basically going to form as 8 minus 3r. So that is going to form as 8 minus 3r, right? So that is going to form as 8 minus 3r. Now I need to get the power of x, which is basically x to the power 5 in the first expansion, right? So if the power is x to the power 5, then my highest power of x should therefore the 8 minus 3x, 8 minus this 3r should be equal to 5. 8 minus 3r should be equal to 5. From this I will get the value of r is equal to 1. From there I will get the value of r is equals to 1. So putting r is equal to 1, so therefore putting r is equal to 1, that is the second term, right? So putting r is equal to 1, I will get the term as 4c1 ax square whole to the power 3 and then 70 upon bx, 70 upon 27 bx, right? Like this. Now this is a coefficient. Now coefficient will be from here, the coefficient of x to the power 5 will be 4c1 a cube into 70 by 27b. 70 by 27b, that is the coefficient of the first term. Now similarly, if I look at the second term over here and then if I try to find out what is the power of x to the power minus 5, so the power of x will be 7 minus r and then minus of 2r, that should be equal to x to the power minus 5, which will basically make it, that is 7 minus 3r minus of 5 should be equal, 7 minus 3r should be equal to minus of 5, right? So that is basically equals to minus of 5. So from here I'll get the value of r as equals to 4. So therefore this is basically the fifth term of this expansion, that is basically giving me the coefficient that is of x to the power minus 5. So similarly putting r is equal to 4 over here, the term will be basically, the coefficient will be basically 7c4 and then we have a to the power 3, that is a coefficient a to the power 3 and then we will have the remaining as 1 upon b. 1 upon b to the power 4, right? So that is the coefficient. Now this particular part and this part are the same. So if I equate it, in this case, I'll get to the value of b. So from this case, this a cube and a cube get cancelled because a is not equal to 0. And therefore, this 1b and this will get cancelled. And we are left out with b cube is equals to 7c4 divided by 4 at 70, and then 27 goes up in the numerator, right? Now solving this will get to the value of b cube. So if I try to solve it further over here, now 7c4 can also be written as 7c3, which is nothing but 7 into 6 into 5 divided by 3 factorial, right? 36. So then it is going to be 35. Then we will have this expression as 35 into 27 divided by 4 into 70. Now interestingly, this is basically 2 times of it. So therefore, we will have 27 by 8. And with this result, you will be having, b as equals to 3 upon 2. So therefore, from this result, you will have b is equals to 3 upon 2. So from this result, you will have b equal to 3 upon 2. Hi, Aryaman Chaturvedi. Okay, so from this we will have b value is equals to 3 upon 2. Now, once we have the value of b as 3 by 2, therefore 2 times of b is basically going to be equal to 3. Therefore, 2 times of b is equals to 3. Therefore, the numeric value of this particular problem is equals to 3. I hope you are also getting the same answer. Are you all getting the same answer? Please let me know. Do let me know in the live chat if you are getting the same answer or not. Right, I hope the solution is clear, very straightforward, right? So once you do the solution, once you get the general term, and from there if you try to find out what is the coefficient, the results are very simple, right? So I hope this is clear to all of you. I hope this particular part is clear to all of you. Do let me know if you have any questions. I'm going to a live chat. Do let me know if you have any questions. Right, so this is a very easy basic problem. So that's why I say that always try to focus more on the basics, because sometimes basic problems also do come up in the JEE advanced also, right? So if you are able to solve this kinds of question also, then also you will be at least able to secure a good marks also, right? And you know that how important is that to secure a +3 or +4 in JEE advanced, right? So with this particular idea, let's move to the next problem. Right? So the next problem is a very interesting problem. Now this is basically a summation of a binomial series. Okay, so it's a summation where you can see it's a very interesting summation, right? And let us see how we can try to proceed to solve these kinds of questions, right? Let's say I want to find out this particular summation. How should I proceed with this summation is very interesting. So let us say I assume, first of all, so these types of questions can be very solved by very standard methods. That is, first of all, assume any expansion like 1 plus x to the power n. So in this case, the expansion is basically like nc0 plus nc1 x plus nc2 x square plus nc3 x cube and so on up to ncn x to the power n, right? That is my first expansion. Similarly, if I replace this x with 1, so if I just interchange this x and 1 and then I expand it, this expansion is going to be nc0 x to the power n plus nc1 x to the power n minus 1 and so on up to last term is going to be ncn, right? Now if I differentiate, so if I differentiate this first expression, then this result is going to be n into 1 plus x to the power n minus 1, and that is going to be equal to nc1, then we will have 1 plus 2 times of nc2x plus 3 times of nc3 x square and so on. Last term will be n into ncn x to the power n. Right. Now let us say this particular equation is equation number 1, and the second expansion, let us call it as equation number 2. Right. Now if I try to observe that what is the required summation. So if I look at the required summation, that is capital X, that is given as nc1 whole to the power whole square plus 2 times of nc2 whole square of it and so on up to 10 times of nc10 whole square of it, right? Now in order to find the summation, what I observe is that if I multiply the first equation and the second equation, And from this multiplication, if I try to find out the coefficient of x to the power n minus 1, then in that case, I will be able to generate the terms like nc1 whole square. Similarly, the term over here, right? So if I just multiply this and then I try to find out the coefficient of x to the power n minus 1, in this case, I am able to generate the required term. I am able to generate the required summation, right? If I am able to take this coefficient of x to the power n minus 1, then I am equal to get the required summation. So therefore, this capital X is nothing but is the coefficient. So this particular term is nothing but it is the coefficient of x to the power n minus 1 in the expansion of 1 plus x to the power 2n, in the expansion of 1 plus x to the power 2n, and therefore your answer capital X will be basically equals to 2n c n minus 1 2n c n minus 1. Now interestingly, here in this case your n is basically equal to 10. Interestingly, if you look at this option, this 10c1 10c2, like, so there your n is basically equals to 10. So similarly, you'll get the value of n is equals to, so that is basically equals to 20 times of uh, so this is basically going to be 20 times of 9, 20c9, right? 20c9. Let me check if I'm not wrong anywhere, right? Just let me check again. So if I do this x to the power n minus 1, but a problem is that I'm not able to secure this particular term, right? I'm not able to get this particular term in the x. I'm not able to get this particular term in the x, but I require that particular term as well, right? So this is the last term, but before that I'm able to capture all the required terms, right? So one more mistake I have done is that so when I do the multiplication, it is not 2 to the power n, it should be 2 to the power n minus 1, right? And into n also will be there, multiplied with n also will be there, right? So that's a mistake, right? So that's a mistake. Okay, please correct. That's a mistake. So therefore this capital X is not going to be equals to this. It is simply going to be equals to 19 seen. So it is going to be 2 to the power n minus 1, and then we will have so this particular n also will be there, right? Multiplied with n, right? So don't forget about that, and that particular thing will basically become 19c 9 multiplied with 10, 19c 9 multiplied with x, and that is basically capital X. So the summation that was given is basically this as follows. So 10 into 19c 9, and therefore we have to find the value of 1 upon 1430 into capital X, and that is basically equals to 10 into 19c 9 divided by 1430. So if you try to solve this further, it is going to be 19c9 divided by 143, and if you try to solve this further, so what I'm going to do is that now 143 is basically 11 into 13, and 19c9, if you just try to write this and then you try to expand it and multiply, you'll get the value is equals to be 646. We'll get the final value or the numeric answer to this question is equals to 646. So therefore, the answer to this particular problem is going to be equal to 646. So okay. So once you're able to get the value of x, then the question is much simpler. You just have to find the what is the required value. What is the required value of x upon 1430? Is this part clear to all of you? Is this part clear to all of you? Ujjwal Mishra. Hey sir, are you from any IIT? Yes, I am from any IIT. Yes, Ujjwal Mishra. Can you please check the description box? You will find all the details. Okay. Okay, Ujjwal Mishra. Is this solution clear to all of you? Is this part of solution clear? Please give me a thumbs up if this part is clear to all of you. So I'm assuming this finding the solution is very important because it's very important idea, right? Now in JEE Advanced, we are mostly going to encounter questions of this particular type, okay, where there will be a summation of binomial coefficients, okay, and they won't be not just very simple, right? So therefore, in order to have this kind of idea, you have to prepare a lot of different types of questions, okay. So it's very important to practice a lot and lot of questions, okay. So what I would suggest is that once you are clear with the basics and once you are able to solve these questions in the live classes also, then you can solve up questions from any previous year questions. And once you're done with the previous year question, I would suggest solving questions from the mock test, okay. Now if you go to the JEE Advanced site, there will be, you will be getting access to all the like mock test, okay. They will be taking up some mock test, okay. So if you have enrolled for the JEE Advanced examination, there will be mock test that you are able to give, okay. So please try to solve that mock test also. You will get a lot of ideas, okay. And if you want to get access to live mock test or test papers, you can always join the Telegram channel, okay. Hi Lalit. Lalit, are you able to get this answer? Please do let me know if you have any questions. Please do let me know if you have any questions so far. I'm going through a live chat. Please let me know if you have questions. All right. So with this part, I hope the solution is clear to all of you. Yes, no. Please do let me know if the solution is clear or not. I hope the solution is clear to all of you. So whenever these kinds of questions of binomial summation or binomial coefficient sum is given, you have to try to solve this question in this particular way only, right? Now, this idea of taking the product and then taking the coefficient is very, very important. So please make sure that you remember these kinds of theorems, okay, because that is going to be very, very useful for your upcoming exam also. Okay, so with this, let's move to the next problem. The next problem is another very interesting problem which involves the user properties, and it's a very interesting and simple problem that came up in the JEE Advanced previous year questions. Okay, so if you look over here in this question, it is said that m is the smallest positive integer such that the coefficient of x square in this particular expansion is basically equals to 3n plus 1 times 51c3, 3n plus 1 51c3, right? So if I look at this problem over here, what I can understand is that I have to find the coefficient of x square. I have to find the coefficient of x square, right? So if I try to find the x square coefficient from all the summation and then I add it, this will be basically equal to 2c2 plus 3c2 plus 4c2 and so on up to 49c2 and plus 50c2 into m, right? And that is basically given as 3n plus 1 times of 51c3, right? Now if you recall, one of the most important property, that is a binomial coefficient, that is NCR plus NC r minus 1 can be given as n plus 1 CR, can be given as n plus 1 CR. I hope this is clear to all of you, right? This is a very important property. So make sure that you remember these kinds of properties, okay? Because this is going to be very, very important and useful for your upcoming preparation also, right? So if you look at these first two terms over here, it is kind of NC. So it is basically, so I can write this 2c2, I can write this 2c2 as 3c3. So in this case, it is like NCR plus NCR minus 1. So this is going to become equals to, this particular first two summation is going to be equal to 4c3, right? Now similarly, 4c3 plus 4c2 is again going to be equal to 5c3. And similarly, as it goes on and at the end till here, the summation will be going to be equal to 50c3. So the summation is going to be equal to 53c. Therefore, it is basically 50c3 plus 50c2 times m is equals to 31 plus 1, 3 times of, 3n plus 1 times of 51c3. Now if I expand it further and try to simplify it out, what I'm going to get is that, so I can write this expression also as, so I'm just trying to simplify this further. So from this simplification, what I can do is that I can write the expression as, now this particular summation, what I can do is that I can write it as 50c3 plus 50c2 times m. Now if I want to transform this into one particular variable so that I am able to take it out as common, in that case, if you just try to do the simplification by yourself also, what you will get is that now this particular part will going to become equals kind of, So it's a all kind of mathematical jugglery that I'm doing over here. Is that what I'm doing is that I'm trying to combine this particular part as 50C2 to 50C3 so that I can take common, or maybe I can convert this part to 50C2. Okay, so if I do that, this particular term is going to become like 50C2 times m square minus 1 is equals to 3n times of, so it's going to be equal to 3n times of 51 upon 3, 51 upon 3, 50C2. So what I did over here is that, now important modification is that I did this one, that is I know that NCR can be written as n by r into n minus 1 c r minus 1, right? So that is what I did, the modification is that, and then I wrote this particular expression over here. Now in this case you will get the modified or simplified expression as m square minus 1 is equal 2 times of m square minus 1 is equal to 51. So from this expression if you put m is equal to, so from this expression if you put n is equal to 5, so from this expression if you put m is equal to 5, you will see that m is basically becoming equal to 16. Okay, so m is basically equals to 16 in this case, right? So therefore, so from this particular expression, once you're able to get this kind of expression, then the solution is much simpler, because you have to find the smallest possible integer m, such that, because your n is also an integer, your m is also an integer, and they are positive integers. So in order to get an integer, the smallest possible values of m that will satisfy this solution is only when m is equals to 16. M is equals to 16, right? I hope this particular part is clear to all of you. Right. I think there is no 2 over here. Okay, there should not be any 2 over here. Yeah, right. So from this you will get the value of n, and the value of n that will satisfy, for which you will get the smallest integer m, that should be equal to n is equal to 5. So therefore the integer answer to this particular question is going to be equal to 5. I hope you are getting the solution. I hope you are able to get the solution. Right? Is this part clear to all of you? Is this part clear to all of you? Are you all getting the answer as 5? Please let me know, are you all getting the answer as equals to 5? Right? Is this part clear to all of you? Do let me know in the live chat if you have any questions, or else we shall move with the next problem. Okay. So if you are clear with this question, let us move with the next problem. Okay. So the next problem is another very interesting problem. Now these kinds of problems has already been asked in mains also, right? And if you look at this problem, it's a very simple problem. It is said that the coefficient of 3 consecutive terms are basically in the ratio 5:10:14. So in order to solve this kinds of question, now why did I take this question? Because it's a very standard question, and this kinds of question has been repeated in the mains also, right? So that's why it's very important to understand and have the basic understanding of it, right? Because the calculation might be a little bit tricky. And also, in order to solve this question, you have to know some properties. That is, NCR upon NC r minus 1 is basically given as n minus r plus 1 by r. Okay, so that is a very interesting property that you have to remember in order to solve these questions. Okay, so if I look at this problem, let us say that r plus 1, and let us say tr plus 1 and tr plus 2 are the 3 consecutive terms. Are the 3 consecutive terms. Okay, now and it is said that the ratio of these terms are basically given as follows. Okay, and similarly tr plus 2 divided by tr plus 1 is equals to 14, or maybe can be written as 7 upon 5, right? So from these two expression I'm going to solve for the unknown value, that is n, right? So I would request all of you to please give it a look, please give it a try. It's a very simple problem, please give it a try. So over here, if you just look at the consecutive terms, and there it said that the coefficient, right? So I have just to find the coefficient also. Okay, so don't go with the terms, we have to basically find the coefficient. Okay, so the coefficient of tr plus 1, that is basically going to be equals to n plus 1 c r, right, divided by n plus 5 c r minus 1, and that is basically given as equals to 2. Now from this I'm going to simplify it further, and with this I will get an equation relating the form. So I will get one equation which is of the form 1 by r plus 1 is equals to 2 upon n minus r plus of 5. And similarly, if I solve the next part, so this is the second equation and this is the first equation, right? So the first equation I'm getting this kind of solution, and on the second part, what I will get is that I will get the value as 5 upon r plus 2. 5 upon r plus 2 is equals to 7 divided by n minus r plus 4. N minus r plus 4, and therefore this is the second part, right? And if I try to solve it further, I'm going to get some equation like n is equals to 3r minus 3, which is also equals to 12r minus 6 divided by 5. So on simplifying further, it is going to be equal to n is equal to 3 times of r minus 1 and 15r minus 15 is equals to 12r minus 6, and from this I'll get the value of r is equal to 3, and once I get the value of r is equal to 3, so n is equal to 6. N is equal to 6. Okay, so n is equal to 6. I hope this is clear to all of you. So therefore, for this particular result to hold true that the ratio of the terms of the coefficient of the consecutive terms are in ratio as 5 is to 10 is to 14, then n should be equals to 6. N should be equals to 6. That is going to be the correct answer. Are you all getting the same answer? Are you all getting the same answer as equals to 6? Did you all get the same answer is equal to 6? Please let me know if you are getting the same answer or not. If you have any questions, you can always put that up in the live chat. Is this part clear? Is this part clear to all of you? Yes or no? Please let me know if you have any questions. I'm going through a live chat. If you have any question, please do let me know. Okay. I hope this is clear to all of you. If you still have any question, you can put that up in the live chat. Right. So let us proceed with the next problem then. Let's move to the next problem. The next problem is a very interesting problem. It's a problem from the multiple choice questions from the JEE Advanced paper, right? Now, initially looking at the expression, anyone would generally be afraid of this kind of expression, right? Looking at this expression over here, anyone can be afraid of this kind of expression, right? So thinking that it's a very difficult question and they will generally omit this kinds of question, okay? But what I would say, if you try to give it a chance, if you try to use the properties, if you know the properties, and if you try to give it a look, this question is a very simple question and it's a one-liner problem. Okay, once you're able to solve this particular part by using the properties, once you're able to simplify this expression by using the properties, this question is a very simple problem. This is a very simple problem. Okay, so I would request all of you to try this problem as a homework. Okay, so please try this problem as a homework. Okay, and let me know if you have any questions. Okay, so what I would suggest is that please try to give it a look. Okay, please try to give it a look. Please try to give it a try. Maybe this question is quite difficult in the first go, but if you try to get the understanding what is this particular part talking about, because if you look this particular bracket as mentioned S upon R, it is basically nothing but SCR, right? So if you look over here, it is basically given as MCI into n plus I CP, and then we have P plus N C P minus I, and it is said that the summation is going from I is equal to 0 to P. So I is a variable, right? I is a variable, right? So if you have this kind of summation, it's very simple to solve, because what you will notice that when you have a continuous product summation like this particular form, it is nothing but, so if you just have this kind of summation, it is very simple to solve it out, right? The variable part gets just vanish out of it, right? So that is what you have to understand and try to apply the idea over here, because if you try to simplify this part further, if you try to do the simplification in the binomial coefficient by using the properties, I guess most probably you will be able to solve it correctly, right? So please try to solve it and tell me the answers you are getting in the comment section. Okay, please solve it as a homework and please comment your answer in the comment section. Okay, please comment your answer in the comment section. Okay, I will be looking for your comments, and with these things I would like to, okay, so with this I would like to conclude my session on binomial theorem. So these are all the questions of the integer types questions and the multiple type questions. Okay. Now similarly, I will take up my some different types of problems which will involve some difficult concepts also, right? So that is going to come up in the upcoming session. So if you are new to this particular channel, I would say that please subscribe to the channel so that you don't miss out any upcoming notification on this particular channel, because we are going to come live every day and we are going to help you out with your upcoming JEE mains and advanced preparation. If you're someone preparing for 2026 and 27, don't forget to join our live batch that we are going to start very soon. Okay, please contact the number that is given in the description box. You can always find the contact details and Telegram channel link from the description. So hope to see you there. Right. With this, I will conclude my session over here and thank you.